For this lesson, we're going to be looking at finding our maximum and minimum values. So to start, let's look at a sample problem. So you're playing football for the Hamilton Tiger Cats and you are kicking a ball for a field goal. If the ball clears the goalposts, you win the game. The path of the ball can be modeled by the function h at d equals negative d squared plus 3d plus 1, where h at d is the height of the ball and d is the horizontal distance. Our goalposts are going to be 2.44 meters high. How can we tell if you win the game? So, if I think of my shape, here you are, ready to hit your football, kick your football all the way into the goalpost. So you kick the football and it flies up in this parabolic shape. And let's just, for the sake of our picture, say you get it in. And it goes over our goalpost, where our goalpost was at a height of 2.44 meters here. Now, how would I know if my curve was going to go over that? Well, I would start looking for my vertex, the maximum value here. How high does my football get? Will it be able to get higher than the 2.44 meters? So this maximum value, or your vertex, is a very common value that is used when solving problems with quadratics. And this parabolic shape is very useful for real-world problems and is often used in physics because most balls being thrown, something being tossed, a lot of bridges, all follow this perfect parabola shape. So when I'm looking for my vertex, there are multiple ways to identify it in a function. The one thing I want to always think of is that my y-coordinate on my vertex is our maximum or a minimum value. If I go back to our example here, my y-coordinate here would have been bigger or smaller than 2.44 meters. And that maximum height would have been the number that would have told me if my field goal would have been successful or unsuccessful. So the ways that I can find this vertex or maximum minimum value is by completing the square, using the zeros, or partial factoring. We're going to be focusing on completing the square and using the zeros. So with example 1, let's start by completing the square. And it's probably been a while since you completed the square, but I'm going to go through the steps again. If you're struggling with completing the square, let me know because I have full detailed videos that you can watch to refresh it for yourself. So when we're completing the square, we're essentially going from standard form to vertex form. So let's start with example 1a here. When we're completing the square, the first thing we're going to do is we're going to put brackets around the first two terms. Next, I see if there is a coefficient in front of the x. If there is, I have to factor it out. In this case, it's just a 1, so I don't need to worry about it. Now here's the completing the square part. That stuff in the brackets, we want to turn into a perfect square trinomial. So in order to do that, we take this negative 12. It's always the second one in the bracket. We take that, we divide it by 2, and we square it. So negative 12 divided by 2 would be 6. And if I square that, we'll get 36. Now what we're going to do with that 36 is we're going to add it in the bracket to turn this into a perfect square trinomial. But we can't just randomly add things to our equations. That doesn't work because then it's not the same. So if I'm going to add 36, I also need to subtract 36 because that's the same as adding 0. So it's not like I really changed anything. Now we still have that negative 7 hanging out in the end, so let's make sure we include that. Next, we're going to take this negative 36 and we're going to remove it from the bracket. Now we need to be careful when we do this because we always need to look for a number in front because we always need to see if there was a number that would have been distributed in or is multiplied by the whole bracket. In this case, there isn't, so we can just have that negative 36 leave our bracket. So that will leave us with x squared minus 12x plus 36. And our minus 36 is left, and our negative 7 is there. Now, because of how we designed this, the stuff in the bracket is a perfect square trinomial. So when we factor it, we can factor it like a perfect square trinomial. If you're not used to that trick, you can factor it the long way, but you should get this, or you should get two of the same bracket. Then let's collect like terms at the end. So we have negative 43. So from here, we can find our vertex. So our vertex is going to be at 6. We change that h value sign, negative 43. Now, if I think of my parabola, my a value is positive. So my parabola would look something like this, and it would be a happy parabola. And it would get lower and lower and lower until I hit a minimum value down here, and I would turn around. So I can write that my minimum value is going to be negative 43. That's as low as it goes. So now let's do a second example where the algebra has one extra step. So for example B, I have y equals negative 5x squared minus 10x plus 2. So I first start by putting brackets around the first two terms. Next, I see if there's a coefficient in front of the x. And here we have a negative 5, so I have to factor that out of the first two brackets. Now when we're factoring it out, we're just going to factor out the coefficient, not the x's. Next, we want to turn the stuff inside the brackets into a perfect square trinomial. So again, we take that second term there, divide it by 2, and square it. So 2 divided by 2 is 1, and if I square it, I just get 1 again. So now, in order to make this into a perfect square trinomial, I need to add 1, but I can't just go randomly adding stuff to our equations. So I also need to subtract 1, like this. Next, we have to take that negative 1 out of the equation. Now, if I look, this 5 would have been distributed into the brackets, and it's multiplied by that whole bracket, including the negative 1. So as it leaves, we need to multiply it by that negative 5 to account for it being in front of the whole bracket. So we have negative 5 equals x squared plus 2x plus 1. And when that negative 1 leaves, it's multiplied by negative 5. So that would give us 5 and 2. Now we can factor the brackets. So because of how we set that up, it is a perfect square trinomial. And then I have plus 7 at the end. So now let's identify our vertex. So that would be at negative 1, 7. Remember to switch the sign on your h. And then if I think of my parabola, it has a negative a value, so it will be downward facing like this, a sad parabola. And my values would get higher and higher and higher until it hits 7, and then it would turn right back around. So that means I have a maximum value of 7. And that would be my final answer. Okay, let's look at our second method for finding our vertex. Next, we could find our vertex using our zeros. So how we do this is we first start by factoring our function. If we can't factor it, we just use the quadratic formula to find the roots. Next, if I could factor it, I can set f at x equals 0 to find the x-intercepts, or again, use a quadratic formula. Then I average the x-intercepts to find my axis of symmetry. In other words, my vertex is perfectly in the middle of my two zeros. So because parabolas are symmetrical, my vertex happens right in between any 2 points that are symmetrical, like my zeros. So I can just find the point that's right in between them. And finally, if I have the x-coordinate on my vertex, I can sub it in to find the y-coordinate. So it sounds like a lot of steps, but it's actually not too bad. So let's start with this example. F at x equals x squared minus 9x plus 20. So the first thing I do is I need to find my zeros. So I do that by setting the equation equal to 0 and factoring it. So two numbers that add to negative 9 multiply to 20. So that would be x minus 5, x minus 4. And then I set both of those brackets equal to 0. So I have 0 equals x minus 5. So my first one is at 5. And my second one is at 4. So if I think of my graph here, I have 1 at 4 and 1 at 5. Now my vertex always happens right in the middle of those two. So we're going to find the x of the vertex. And how I do that is I add my two zeros together and I just divide by 2 to find the spot right in the middle. So that would give me 9 over 2. Finally, I need to find the y of my vertex. And I have an x-coordinate, so we can just find the y-coordinate. So my y-coordinate would be the same as f at 9 over 2, like this. So let's sub in 9 over 2. 9 over 2 squared minus 9 times 9 over 2 plus 20. That would give me 81 over 4 minus 81 over 4 plus 20. Oh, sorry. Had an extra little 4 there. That should have been a 2. My bad. There we go. Now let's make some common denominators real quick. We're just going to put them all over 4. And that will equal, sorry for my bad form here, I'm just running out of room. Negative 1 over 4. So therefore, the vertex is at 9 over 2, negative a quarter. Like that. Okay, let's do one more example. So for B, we have 5x squared plus 7x equals 3. So in order to find our zeros, which is the first thing we have to do, we have to set this whole thing equal to 0. So we'll have 5x squared minus 7x minus 3 equals 0. And I can tell you right away that this thing does not factor. If you were on your own, you'd want to give it a try, but if you can't really find it right away, you can always just throw it into the quadratic formula. So for my quadratic formula, I have A, B, and C. And let's sub all that in to find our zeros. So I'll have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we'll have 7 plus or minus the square root of 109 all over 10. And for our purposes here, we can have decimals. That's always a fair question to ask. Can I use decimals? Can I not? But usually I would have that you're allowed to round. So in this case, we can have decimals. So if x equals 7 plus root 109 over 10, and we'll have x equals 7 minus root 109 all over 10. So that will give us x equals 1.744 as our first zero, and our second one will be negative 0.344. Now we have our two zeros, so the next thing we want to do is we want to figure out what point is right in between them. So our x of our vertex, we always add our two zeros together. And I'm going to divide that by 2. And that will give us 1.4. And now we need to sub that in to find the y value of our vertex. So the y of my vertex is just f at 1.4, like this. And now let's fill that into our equation. So we will have 5 times 1.4 squared minus 7 times 1.4 minus 3. And that will give us -3. So our vertex like this. So again, our steps are find our roots. So you can factor it or you can use the quadratic formula. Find the middle of them, add them, divide by 2, and then sub that value in to find y. All right, let's do a couple quick word problem examples and then we're done. So for example 4, a ball is kicked from the ground across a field and makes a parabolic trajectory followed by the equation h at t is negative 4.9 t squared plus 58.8 t, where h at t is the height of the ball in meters and t is the time of its flight in seconds. What we need to find out is A, what time will the ball be at its maximum height, and B, what will the maximum height of the ball be? In other words, we're going to be completing the square. So here's what we're looking for here. This is our situation. We have our height, we have our time, and a ball is kicked from the ground. So it's sitting on the ground, goes up like this, comes back down, and hits the ground. So we need to find our vertex here. It's up to you how you want to find it. You can try to complete the square, or you can find the zeros. I'm going to go through and factor it, but it's up to you. So we're going to take h of t equals negative 4.9 t squared plus 58.8 t. And I'm just going to factor some stuff out of this. So I can take out negative 4.9 t, and I'm left with t minus 12, like this. And then I'm just going to set this whole thing equal to 0 in order to find my zeros. And then I take my brackets and set them equal to 0. Negative 4.9 t equals 0. So we'll get that t equals 0. That's this one here, which makes sense because right when it starts, it was hit off the ground. And then I have t minus 12 equals 0, so t equals 12. So over here at 12 is when it hits the ground. So now let's find our one coordinate of the vertex. So our t of the vertex, if you will. So we're going to take those two, add them together, and divide them by 2. That will give us 6. So that happens at 6. And now we need to figure out the matching height. So h of 6 will be negative 4.9 times 6 squared plus 58.8 times 6. And I'm just going to put that into my calculator because there's a lot of decimals there. And that will give us 176.4 meters. So at A, what time will the ball be at its maximum height? At 6 seconds. And what is the maximum height? 176.4 meters. Okay, one last example. A movie theater sells 3,000 tickets a day at a price of $6 a ticket. It has been determined that for every 30-cent increase, the price of the ticket would get 100 less customers. For the first part, we want to figure out what their current revenue would be. So for A, they currently sell 3,000 tickets at $6 a ticket. So their current revenue is going to be equal to $3,000 times these $6 a ticket. So their current revenue is $18,000. So for B, what would their maximum revenue be should they decide to alter their price accordingly, and what should they set that price to obtain the maximum revenue? So let's start by setting up an equation for their revenue. So when we have a revenue equation, our revenue is always our tickets sold. So how many tickets did we sell? And what was the price of the ticket? Just like we did for our current revenue, we had 3,000 tickets and we sold them at $6 a ticket, so we just multiplied those together. So now, if I think of how many tickets I sold, if I look up here, I have 3,000 tickets. But then each time I increase it by 30 cents, we lose 100 customers. So we're going to start by saying, let X represent the number of price increases. So if I go back to my equation, I start with 3,000, but I lose 100 every time I increase that price. Now, if I look at my price, I started at $6, and then each time I'm increasing by 30 cents, like this. Now, we need to find the maximum of this equation. So let's start by multiplying it out, and then we'll complete the square. So I'm just going to multiply this out, so don't forget to use FOIL and multiply everything. I'm just going to rearrange this so that we have it in the proper order, and I will collect some like terms. And now, because I'm looking for the maximum, I'm just going to complete the square. I think that's the most straightforward method. So again, I start by putting brackets around the first two terms, and then I factor out the number that's in front of the x, so negative 30 minus 10x. Now remember, we need to find that magic number that turns the brackets into a perfect square trinomial. So we take that second number, divide it by 2 and square it. So negative 10 divided by 2 is negative 5, squared is 25. So now x squared minus 10x plus 25 minus 25, and that plus 18,000 is still just hanging out on the end. Now I need to get this negative 25 out of there. And remember that that negative 30 is multiplied to everything. So when it leaves, it does need to get multiplied by that negative 30. So we'll have plus 750 plus 18,000. Now we can factor the stuff in the brackets and collect like terms at the end, like this. So now if we look at our vertex, it is at 5, 18, 750. So this here is our max revenue. And this here is the number of price increases that makes our max revenue. So that means 5 price increases. So now what we were asked is, what would their maximum revenue be? That's this. And the other thing is, what price would they have to charge in order to make that? So that happens after 5 price increases. So our price would be $6 plus 5 price increases. So that would give me $6 plus, and that would give me $7.50. So let's write out our therefore statement. Therefore, the max revenue of $18,750 occurs at a price of $7.50. And that is our final answer.